Okay, part 2 of test 3. Use the law of sines to solve the following triangle. So we have got a side and we've got two angles. So if we know two angles in a triangle, we can figure out the third one by subtracting from 180. So if two of our angles are 44 and 49, that means that the third angle is going to have to be 87, so we'll call it 87.0 degrees. Now we can set up our proportion. So again, it doesn't matter which whether you do side over angle or angle over side, as long as you stay consistent. So I'm going to do, I think, side over angle because that's what the cheat sheet says. So 5.00 over the sine of 87.0 degrees equals side B over the sine of 44.0 degrees, and we'll use the same ratio, 5.00 over the sine of 87.0 degrees equals side C over the sine of 49.0 degrees. So all we have to do now is cross multiply. So 5.00 times the sine of 44.0 degrees equals B times the sine of 87.0 degrees. Divide both sides by the sine of 87. And we get B is equal to 3.48 inches. And if we do the same thing for C, we're going to get 5.00 times the sine of 49.0 degrees divided by the sine of 87.0 degrees is equal to C. So that's going to give us 3.78 inches. All right, that's the law of sines. Now we need to use the law of cosines in problem 16. So we're given all sides, no angles. So it's up to you which angle you want to solve for first. This is going to be a three-part process. So let's just use c squared equals a squared plus b squared minus 2ab cosine theta c. And let's plug that in. So we've got 19.98 squared equals 25.61 squared plus 20.58 squared minus 2 times 25.61 times 20.58 times the cosine of theta c. All right. So let's see here. 19.98 squared is 399.2004. I'm going to keep all of my decimals for right now until I'm done all of the adding and subtracting. You should really round at the final step. So try to hold on to as many decimal places as you can within the calculations and only round at the end. All right, 25.61 squared is going to be 655. 0.8721, and then we're adding to that 423.5364, and we're subtracting from that 1054.1076 times the cosine of theta c. Okay, so let's get all of the numbers over onto the left-hand side. So that's going to give us negative 680.2081 equals negative 1054.1076 cosine of theta c. Divide both sides by negative 1054.1076. So we've got cosine theta c is equal to 0.645292852. You don't have to write all those numbers in necessarily, but keep them in your calculator. And so now theta c is going to be the inverse cosine of this. And now that we've finally made it to the end, we notice that we have 4 significant digits, so I'm going to call my angle 49.81 degrees. Okay, great. So now we don't have to use the law of cosines again. We can actually use the law of sines on the next step since it's a lot faster and easier to use. So we can say side C 19.98 over the sine of 49.81 is equal to, let's solve for side A. Side A, oh, we know side A, I'm sorry, we're solving for angle A. 25.61 over theta A. So we're going to cross multiply. We've got 19.98 times, whoops, that's supposed to say sine of theta A, times the sine of theta A equals 25.61 times the sine of 49.81 degrees. Divide both sides by 19.98. We've got sine of theta A is equal to 0.9792. So theta A, and again, there's more numbers in my calculator than that, so leave all the numbers in your calculator. Can't say it enough. It's going to be the sine inverse of 0.9792, etc. And that's going to give us 78.29 degrees. And then finally, to get angle C, we're just going to subtract from 180. So I'm just going to put it over here, theta C. So what have we got? 49.81 and 78.29. And we're going to subtract that from 180. And that leaves us with 51.90 degrees. So there we go. There are all of the angles in the triangle. These law of cosines problems, they're a lot, but it's important to know because sometimes you're in a situation where you're trying to measure distances and you may be doing some kind of work involving construction or some sort of civil engineering, and this is what you're going to need to use. So it is important that, especially if you're going into a field like that, that you're very comfortable with this. Okay, next. It's a law of cosines problem disguised as a word problem. So let's take a look at this. Jeffrey and Diana left the airport at the same time. Jeffrey flew at 510 miles per hour on a course with a bearing of 50 degrees. So let's just draw ourselves a little picture. So 50 degrees is about here. So here's Jeffrey, 50.0 degrees, flying at 510 miles per hour. Diana flew at 580 miles per hour on a course with a bearing of 130 degrees. So 130 degrees is somewhere like about here. So that's 130 degrees. And this is 580 miles per hour going this way. So they're flying apart from each other. And the question is, how far apart were they after 3 hours? So we can actually change our vectors. So instead of using miles per hour, which you may have been tempted to do at the beginning of the problem, we actually want a distance. So 510 miles per hour times 3 hours is going to give us 1,530 miles is how far Jeffrey flew. And then Diana, 580 miles per hour times 3 hours is going to give us 1,740 miles. So we want to know what is the distance between them. So we're going to call this side C. We know that the angle between these two guys, so this angle right here, is going to be 80 degrees. So we've got everything we need for the law of cosines. So let's plug it in. C squared equals, and it doesn't matter which one you call A, which one you call B. So I'm going to call the left one A and the right one B. 1740 squared plus 1530 squared minus 2 times 1740 times 1530 times the cosine of 80 degrees. And there's not a whole lot to do except actually just plug all of this into your calculator. So that's not so bad. So C squared is okay, so this is going to be 3027600 plus 2340900 minus 924572.3 and change. So in the long run, that those decimals aren't going to matter because these numbers are so massive. So let's see what we've got here. So C squared is equal to 4443927.643. Take the square root of both sides. And if you notice, two significant digits here, 2 significant digits here, 4 here, 3 here. So we're going to go with 2 significant digits. So rounding to 2 significant digits is going to give us 2,100 miles. Oh, no, I said round to the nearest tenth of a mile. That's my bad. So, all right. So when I don't tell you anything, always assume significant digits, unless I tell you otherwise. So make sure to read their directions, because that's part of test taking. And always go back and double check that you've done everything right, because it's very easy to skip over a direction like that. So 2108.1 miles. All right, so that's a slightly easier law of cosine's problem, slightly harder law of cosine's problem. Okay, next. The Amazon River flows south at a rate of about 2.88 kilometers per hour. So it's flowing due south, 2.88. Suppose you want to row a boat due east, and you row at a rate of 8 miles per hour. So you're rowing, let me move this down a little bit. Okay, so the river's flowing south. You want to end up directly across the river, but since it's pulling you downward, you're going to have to row somewhere over here so that when the river pulls you downward, you end up where you want it to be. Okay, so the question is, what angle theta do you need to row at? Well, so this is also going to be 2.88. You row at 8.00, and we have the opposite side and the hypotenuse, so that's going to be sine. So we can say sine of theta equals 2.88 over 8.00. So theta is going to be the sine inverse of that. Okay, so I didn't give you a specific thing to round to, so we're going to go by significant figures. So that's 3, and we're going to say that's 21.1 degrees. Okay, the questions 19 through 30 are similar to what we've already done, so I'm not going to go through and re-explain them, but I will send out the answer keys so that you can check your answer and make sure you did it. But they're done the same way as problems that we've already done in this packet. So I'm going to skip over those. Same thing all the way up through, so questions number 19 through 30. So I'm going to skip all of those, and I'm going to move on to 36. Yes, it does jump from 30 to 36. That was just a weird typo glitch thing, so don't worry about that. So add or subtract the following complex numbers. Again, we just add like terms, so we're going to get -1 minus 2i. We're going to get -7 plus 6i. We're going to get -28 minus 7i. We're going to get 25 plus 25i. And then we're going to get 10 plus 10i. Okay, multiply the following complex numbers. So we got to distribute -27i minus 6i squared. So that's I squared is -1. -1 times -6 is a +6, so it's going to be 6 minus 27i. Letter B, we've got -4 minus 4i minus 2i minus 2i squared. So that's going to give us, again, so this is -1 times a -2. This is +2 plus -4 is going to give us -2. Combining these terms, we're going to get -6i. And then finally, 30i minus 18i squared minus 5 plus 3i. So the negative 1 times the negative 18 is going to be a positive 18, minus 5 is a 13, and then 30i plus 3i is 33i. Okay, and then finally, rationalizing the denominator. So we're going to multiply by the conjugate, which is 2 minus I, top and bottom. So on the top, we're going to get 6 minus 3i minus 8i plus 4i squared. And on the bottom, we're going to get 2 squared minus I squared. So the top is going to simplify. This is negative 4. 6 plus negative 4 is 2 minus 11i. And this is 4 minus negative 1, so that's going to be a 5. You can also write this as 2/5 minus 11/5 I. I really don't care which way you write it. Whichever way you like better is fine with me. All right, next. We're going to multiply by 3 plus I, top and bottom. So this is going to give us 15 plus 5i over 3 squared minus I squared. So that's going to be 15 plus 5i over 9 minus negative 1. So that's going to be 10. We can factor out a 5. That's going to be 1 plus I. Inside the 5 and the 10, we can do a little canceling. So we've got 1 plus I all over 2. And then finally, we're going to multiply by 5 minus 5i, top and bottom. And we've got 35 minus 35i plus 10i minus 10i squared all over 5 squared minus 5i squared. So what have we got? Negative 1 times negative 10, that's going to be a positive 10. Plus 35, that gives us 45. Negative 35i plus 10i is minus 25i. And then 25 minus, I'm going to work this one out. 25 minus, that's going to be 25i squared. So we've got 45 minus 25i. And then this is negative 1 times negative 25, so that's going to be a plus 25. 25 plus 25 is 50. And again, we can pull out a 5. So we've got 9 minus 5i on the inside. We could do some canceling. And our final answer, 9 minus 5i all over 10. All right, and that's it for all the Tech Math 1 stuff.